Good morning. This is section 4.2. Our learning target today is I will be able to identify if polygons are congruent by definition. So let's get started. So we first need to find out, what does it mean when two figures are congruent? So please write this in your notes. The learning target is still at the top. The definition of two figures being congruent is when they have exactly the same shape and the same size. And if they have the same shape and size, all of their corresponding parts are going to be congruent. So all of the sides that are corresponding will be congruent, and all of the corresponding angles will be congruent. So write that definition down, and then I have 4 examples and 4 non-examples that you can put in your notes. So I'll give you a minute to write that down and take down the first. Actually, I'll scroll down a little bit so you can get the first 2 examples maybe. There you go. Pen is going to be funky again. Worked last hour. So quick do this and just get this out of here. There we go. Last hour. And let's see. Maybe now it will work. Oh, it's working. Okay, good. That's all I needed. All right, so here are some examples of what congruent figures are. I'll go through the examples first, and then we'll talk about the non-examples. So these 2 are squares, even though one of them is rotated a little bit, tipped on its point. Notice that all of the sides are congruent. So they have all of this side is congruent to this side, but they're all the same length. So we know it's a square because all of the sides of the first square are equal to each other, and they're also equal to the corresponding sides of the other square. And all of the angles of the first one are 90 degrees, and so are all of the angles of the second. So those are corresponding parts and sides. Corresponding sides and corresponding angles are congruent. So that means that the 2 figures are congruent to each other. They're the same size and same shape. We have 2 hexagons here. Again, this is, and we'll learn this later, but this is called a regular hexagon because all of the sides are equal. But the important part is looking from one hexagon to the second hexagon, all of the corresponding sides and angles are congruent. Same size, same shape. Let's look at, oh, actually I only have 3 of each. I thought I had 4. Let's look at this third one down here. These are also congruent figures. These are trapezoids. On these, not all the sides are the same, but if you look, corresponding sides are congruent. So this side here corresponds to this one here because it's just been rotated 180 degrees. This side here corresponds to this side here, and those are congruent. The top of this trapezoid, the first trapezoid on the left, is congruent to the corresponding side of the other trapezoid that's on the right. Again, this second one has been turned upside down 180 degrees. It's just been rotated. So the top of this one corresponds to the bottom of this one. And you can tell because this is the shorter base, this one's the shorter base. And then the bottom of this one has the 3 tick marks, and that one matches up with this one. And those are corresponding sides and they're congruent. And we could also look at the angles. This angle and this angle are congruent to each other, but on the other figure, they're also congruent to the corresponding angles on the other one. And these have 2 angle marks, and those correspond to these. So all corresponding sides and angles are congruent. So these 2 figures are congruent to each other. They're the same size, the same shape, and corresponding sides and angles are congruent. Let's look at the non-examples. First of all, circles aren't polygons, but they're not congruent because they're the same shape but not the same size. So those would not be congruent to each other. They're not polygons, so but we're talking about congruent figures because these don't have sides. But let's look at the second one. These 2 triangles, they're the same, they're both triangles, but they're not the same size, they're not the same shape. Corresponding parts are not congruent. So in the second one here, all of the sides are congruent to each other, but this one here is the only one with 1 tick mark. And not all of the angles are congruent to each other. So these are not congruent. And then the stars at the bottom look like they're about the same size, but they're not the same shape. One of them has 5 points and one of them has 6 points. So those are also not congruent because the corresponding, maybe the sides are the same, but this one doesn't have the same number of sides as the second one. And the angle measures are not the same either. So the ones on the left are congruent to each other. These are examples of congruent figures. These are examples of figures that are not congruent. So just so you get an idea. And we're going to be talking about congruent figures today. All right, unless I hear from you otherwise, I'm going to assume I'm giving you enough time. So when we have congruent figures, we can write what is called a congruence statement. And that term is really important. It's a statement that says how they're congruent, and it's important that it's written in the correct order. So these 2 triangles are congruent. You can see that by the corresponding sides are congruent. This one has 1 tick mark. Here's the corresponding side. Side BC has 2 tick marks, and that corresponds to side EF. Side AC has 3 tick marks, and that corresponds to side DF. And the corresponding angles B and E have 1 arc mark. Angle C and angle F have 2 arc marks. Angle A and angle D have 3 arc marks. So corresponding sides and angles are congruent. This second triangle has just been rotated a little bit. If they give you a congruence statement, you can use that congruence statement to name your corresponding angles and sides. And you can do it by looking at the diagram, or you can use it, you can write these by using the congruence statement. So I'm going to show you both ways. Sometimes they'll just give you the picture and they'll ask you to name the corresponding angles and sides, and then you're going to have to use your picture. I would first, from your picture, write the congruence statement. But if they give you both, or if they just give you the congruence statement, you can still write the corresponding angles and sides. So let's do this first by looking at the picture. And let's write down what the corresponding angles are. So I see that I have angle A, B, and C in my first triangle. So I'm going to write angle A is congruent to what? And then we're going to write angle B is congruent to which angle in the second triangle, and then angle C. Is congruent to which angle. So we're going to look at the diagram. So the first way to do this is by looking at the diagram. So I have angle A has 3 arc marks. I need to find the angle on the other diagram that also has 3 arc marks. And that is going to be correct. Somebody's putting things in the chat. Angle D. And that would be angle D. So then let's look at angle B has, try a different color. Let's try purple. This has 1 arc mark. We need to find the other one that has 1 arc mark. That would be angle E. And then angle C has 2 arc marks, and so does angle F. So you can do these by looking at the picture, the diagram, and matching up the angles by their arc marks. We can do the same thing with the corresponding sides. So let's take the one that has 1 tick mark. Remembering that side AB is a segment. So I'm going to put the little segment marking up there on top. Without the segment marking, that means the length of AB, but they don't give me what number it is. So if we're just talking about the side itself, in the picture, we name it as segment AB. So let's find the other side that has 1 tick mark, and that would be DE. Very good. Then let's find the one that has 2 tick marks. That would be side BC. And you don't have to do these in this order. This is just my way of trying to be organized so I get all of the sides. BC has 2 tick marks. I'm going to find the one that has 2 tick marks. That would be side EF. Thank you for the people who are putting that in the chat. I appreciate that. Then the last one has 3 tick marks. So I'm going to say side AC. And that corresponds to the one that has 3 tick marks, which would be DF. So that's how you can do it using the picture, the diagram. I'm going to show you another way to do this, which will be kind of a lifesaver, because sometimes they will take your first diagram and they won't just rotate it, but they'll also flip it, and it is going to trick you. All right, so there is another way to do this by using the congruence statement, if they give it to you. Sometimes they will give you the diagram and they'll say, write a congruence statement. So you need to use this, and you need to write this triangle ABC is congruent to triangle DEF. You have to put the letters in the right order. And if you write the first triangle as triangle ABC, the second triangle is not always going to be in alphabetical order. You have to put it so that the corresponding angles and the corresponding sides match up. So here's how to use it, the congruence statement, if they give this to you. And if they don't give it to you, you can use this information to help you write a congruence statement. So I'm going to highlight. So notice if they give me this as being true, they're saying these two triangles are congruent, and they give it to me in the correct order. Notice angle A is congruent to angle D. They match up because they both are listed first. Angle B and angle E are both congruent to each other because they're both in the middle or second in my congruence statement. And angle C and angle F are congruent because they're listed last. That will always work. So when you write your congruence statement, you have to make sure that you're putting this second triangle in the correct order for your when you name it. It also works, and some people find that the angles are easy to pick out because you just need to look for the angle markings. The sides are sometimes tricky. So let's look at this. Notice that I can AB. If I put AB, it should read in the same order on my second one, DE. If I'm trying to find which side is congruent to BC, it would be EF, because BC are my second and third letter. I would need to name EF in the same order. And finally, A and C go together, and D and F go together. So I list it from the first to the last and the first to the last. Now, in regular geometry, which you're in, we are not too picky about the order. I would prefer, though, that you guys try your hardest to get these in the correct order. So if you had said AC is congruent to FD instead of DF, notice AC, I'm going in this order from A to C. F to D is going in the reverse order. So that's technically not correct. If you were in accelerated geometry, then you would have this counted as wrong if you put that answer, because it's not in the same order. If I go from A to C, I need to go from D to F. So use your congruence statement to get your sides listed in the correct order. So hopefully that makes sense. And as we go along, maybe you'll see that what I'm talking about with that when we do some of our other examples. So that's a congruence statement, and sometimes you will need to write these congruence statements. I think the easiest way to write your congruence statement is by looking at the angles, and then check to make sure you have it right by looking at the sides. So look at to see that angle A corresponds to D, so I would put D first. And let me just quick do this. What if I had said triangle CAB, C-A-B? Because I could write that first triangle. I don't have to write it alphabetically. I could write it as C-A-B. Well, then I would say, okay, I'm starting with my C, which has 2 arc marks. Which angle corresponds to angle C? Which one would I put first here? By looking at my diagram, if I had to write this congruence statement. Somebody unmute or put it in the chat. Which angle would I put first? Thank you, Miguel. C and F correspond. What corresponds to angle A would be D. What corresponds to angle B would be E. So it depends on how they write the first triangle as to, whoops, and I forgot my little triangle in here, as to how you write the second triangle. So that's kind of what I'm talking about. And both of these congruence statements are true. So they can write them either way. And I also could have written this first triangle in a few different ways. All right, we're going to learn some properties. So if we have congruent triangles, we can use these 3 properties: reflexive property, symmetric property, and transitive property. Let's talk about each of these. Reflexive. When I think of reflexive, I think of a reflection when I'm looking at myself in the mirror. That means it's congruent to itself. So think of looking at them in a mirror and you see yourself back, right? You don't see a picture of your friend. It's a picture, you see the reflection of yourself. So the reflexive property, triangle ABC, is going to be congruent to itself, which is triangle ABC. So that's what the reflexive property is. It's always congruent to itself. The symmetric property deals with the order that things are listed. And these words shouldn't be new to you. You've seen reflexive, symmetric, and transitive before, but we're now using this with triangle congruence. So here's what this is saying. If triangle ABC is congruent to triangle DEF, then we can do it in the reverse order. We can just then say triangle DEF is congruent to triangle ABC. So we just reverse the order. And that's symmetric. Again, having these in your notes will help you on your quiz and test and your homework. Finally, the transitive property. This is, I suppose I need to put that in parentheses. This is when we link them together. So if, and you can tell it's going to be transitive because it has the and in there. This is an if then for the symmetric. This has an if and a then, but there's an and in the middle. if triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle JKL. These two are congruent. So if one thing is congruent to the second thing, and the second thing is congruent to a third thing, then the first is congruent to the third. So we're going to link those together. So then triangle ABC is congruent to triangle JKL. So these two things in the middle are congruent to each other. And the DEF is congruent to the ABC, and the DEF is congruent to the JKL. So ABC is congruent to JKL. So we're going to link these two together. Let's make that a little bit nicer. So that's the linking property, where we can link the first and the last together. Any questions on that? All right, so let's move along. So here's an example of the reflexive property. Remember the reflexive property where it's congruent to itself. And I'm going to bring this in along with that piece of information about naming things in the correct order. The reflexive property, and I don't know how much I can say this. Let's see if I can find my, there we go. This reflexive property, put a star by it. Put 2 stars by it. Because you will be using the reflexive property in geometry a lot. So we already, and I didn't put stars by these, but you should have stars in your brain for vertical angles. Know what vertical angles look like and know that they're always congruent to each other. The second thing that we will use a lot is the linear pair. Know what they look like. So they form a straight line. They're adjacent, they're next to each other. They add up to 180. That's a second thing. The reflexive property, you guys, all the time, we're going to be using reflexive property, especially when we are doing proofs. We will get to doing proofs at the end of this chapter. So here we have 3 diagrams. And we color coded them so you can just see, but we have 2 triangles that are next to each other. We have 2 quadrilaterals that are next to each other and 2 more triangles. Notice that they share a side. So here we have a red triangle and a blue triangle. They want to know which segment is shared by both sides. So in the red triangle, I have BC. Actually, let me use red. I can't do that. Let's try this again. So I have side BC in the red triangle and I have side BC in the blue triangle. They share a side, they're congruent to each other. So we could do this. Those are congruent to each other. So BC is congruent to itself, BC, that's reflexive property. So when you have a proof that you're doing, if you're trying to prove that these triangles are congruent, you would need to prove that the sides that you have corresponding sides and angles are congruent. These two sides by the reflexive property are congruent to each other. Let's look at the quadrilaterals here, our little trapezoids. In the red one, I have side CF. So I'm starting up here and I'm going down this way to name that side. If I am going to be naming the side that's congruent, most people would say CF. But if the angle that corresponds with C is actually F. So I would start here and name it this way. They're still congruent to each other. But that's what I'm talking about when I say the reverse order. If you said CF is congruent to CF, we probably won't count it wrong. But if you were trying to write a congruence statement, your congruence statement would be wrong. So you have to get them in the right order, because angle C here, this angle right here, is not the same as this one. It's the same as this one down here. You can see because this other one has been rotated. And then let's take the third diagram. Here we have BD. And in the chat, tell me what would be the corresponding side, if you could write it in the correct order. So side BD is congruent to what? Correct. DB. Notice we're starting with, so these two sides are congruent. Angle B is actually congruent to angle D. So if we would start with B and go down to D, we'd have to start with D and go back to B. Again, if you put BD is congruent to BD in a proof, I won't count it wrong. But if you write a congruence statement backwards, it is wrong, because you have to write your congruence statement with the letters in the correct order. So hopefully you kind of see what I'm talking about there. All right. So I would like you to draw this little diagram and try to name the corresponding angles and sides. And down here, number 5 and 7, they ask for you to write congruent statements. Triangle ERG, and of course, they're starting with the second triangle, and that's okay. How would you name the letters of the first triangle in the correct order? So try to do those 8 things. I will give you a couple of minutes here. So do this on your paper, and then I'll ask for people to tell me what you got for your answers. All right. So in the chat, you can tell me number one, what did you get? And I want everybody to participate. You just put the letter that you put, and you can do it privately to me. What letter, what angle corresponds to angle S? Fabulous. Angle G. Now put two letters. What side corresponds to GR? Grr. Very good. SA. Number three, angle E corresponds to what? Very good, angle T. And again, you can see this from the congruence statement that they gave you. Angle S is the first letter listed, so it corresponds to angle G. GR are the first two letters of this second triangle. We need to do SA in that same order. Angle E is the last letter here, so we would line that up with angle T. What about AT? Very good, RE. Here's, actually, let's go to number 6 and 8. Let's finish those and then we'll do the triangles. So number 6, EG, corresponds to what? EG. This side here, what does it correspond to? I don't have anybody who has it right yet. Oh, I do now. It is TS. So if you said ST, make sure that you're looking at, we started with, get my pencil, my pen up. We started with E and we went to G, EG. We have to go from T and name S, so it's TS. So you have to get those in the right order. This, if you put in the wrong order, you would get it wrong. If you put ST, you would not get the points for that. And then angle R corresponds to what? Correct, angle A. So angle R is the middle letter, angle A. How about triangle number 5, triangle ERG? So if they are writing my congruence statement now in a different order, ERG. Some people with it correct. That would be TAS. So again, let me pick a different color. They did ERG in this order. E to R to G. We'd need to do TAS. So we have to do them in the correct order. And then what about REG? Very good. So they did R, E, then to G. So you would need to do A, T, then to S. ATS. So you study this. You should be able to answer questions like this. If you can do this correct, you will get a lot of points on quizzes and tests because we've got a lot of these kinds of questions. And sometimes the diagrams we give you are tricky. So if you can't figure it out from looking at the diagram, please use the congruence statement to help you answer these questions. All right, so we are going to do another maze like what we did on Monday in class. This is an in-class activity. You'll have about 25 minutes by the time I'm done explaining this. So I will open the link Some people might have already clicked on this. But I think I've got this. Yeah, so it'll be on this page when you open it up. So click on the link that is in today's folder. It says 4.2 PD congruent statement activity. Refresh the page if you need to. Click on that link. It'll take you to this. And this is similar to what we did before. The starting point is again at the top left. We did the first problem for you. So they give you a congruent statement. Triangle ABC is congruent to triangle DEF. You don't even need a calculator for this one. They then want to know, what is angle B congruent to? Well, it's the middle letter, so we would use the middle letter on the other one. Angle E, follow that by either coloring it in or drawing a line or highlighting the path, and then this is the problem you would do second. Some people had an issue with, not in this class, but with my other class, of being able to see it because it's kind of small. If you use two fingers and put your two fingers on your trackpad if you don't have a mouse, and then make it bigger. And then you can kind of move it around with two fingers to kind of find where you want to be. And then you can color it in, and you can keep scrolling in and out with your fingers, but you have to use two fingers at a time. I practiced on this just because somebody was having trouble, and I wanted to make sure, because I'm always using my mouse, but I just use my trackpad, and it will work that way. So use two fingers to zoom in and zoom out. All right. So I will open that so you can go. Oh, before I do that, I want to quickly. So there are the answers. So I want you to screenshot your completed maze and post it in the comments in today's folder. There's a discussion board in there for you to post your answers. I think on Monday I had you guys just say that you were done, and for me to check. I think it's easier if you just put your screenshot in there. I can still go in here and look. And I had to do that for a couple of people. And then your Schoology homework. And I will open that in a few minutes here after I see everybody started on the activity. It is not on Delta Math. It is in Schoology. I highlighted it. It's going to show up as looking like an assessment, but you can try it up to 20 times and it'll show you if you get it right or not. So keep trying it until you get all of them correct. There are 10 questions and you can try it up to 20 times. It'll give you your highest score. So it's in Schoology, not in Delta.